For problem number 2, you have a capacitor, a circuit with 2 resistors here and a battery here. In the first part of the problem, you're supposed to find how much current goes through each of these sections and the charge in the capacitor. So you know that at steady state, there's no current flowing through here, so you can figure out that the current only depends on this circuit right here. So based on that, you can see that EMF, using the loop rule, that EMF is equal to I times these 2 resistors. Solving for I, you find that that all of these, that EMF over R1 plus R2 is equal to I, and that is equal to current at A, E, B, and D. To solve for Q, you know that Q is equal to delta V equals to Q over C. Using that, you know that that delta V is equal to IR, and I, is EMF over R1 plus R2, and that R, in this case, is just R2, and then you can see that that's equal to Q over C. And solving for Q, you get Q is equal to EMF R2 over R1 plus R2 C times R2. And that's the first part. The second part of the problem asks you to find the currents at the locations when the switch is opened. Now you know that when the switch is open, that there's no current going to be flowing through here, and only this part of the circuit should be taken into consideration. When the switch is open, the charge has not yet left the capacitor, so you know that I times R2 is equal to the change in voltage at C, the capacitor. So here. So you know that I, in the previous problem, is equal to EMF over R1 plus R2. Multiply that by R2, that is equal to delta V. And you know that using the loop rule, that delta VC plus delta V of R2 is equal to 0. So that's how you get this part here. And for solving for just I, all you have to do is you simply have just this I. This is your I. So I, now since you're only taking into account this circuit here, only C and D have current flowing through it, but A, B, and E do not, because there's no current since the switch is open. So know that I is equal to EMF over R1 plus R2. Q is the same thing as problem A, which is just EMF R2 over R1 plus R2. At the last part of the problem, you're asked what is the current. What is the current when the switch is open after a long time? And you know that since the capacitor has discharged, there is no current, and therefore there's no Q. So Q is just equal to 0, and I is equal to 0 at all places. And that's the end of the problem.